Good morning, Doctor. We hope you are in good health. We are from Group 6 and today we will present to you about how does RAAS in endocrine system work. Before we start, let me introduce you to the member of this group. My name is Istifa Ajwa and the other members are Muhammad Zulhilmi, Nur Liana, Nur Naima and Siti Zulaika.
What is RAAS? RAAS, or its full name, renin-angiotensin-aldosterone system, is a hormone system within the body that is essential for controlling systemic blood pressure, renal blood flow, and glomerular filtration rate. It will influence the cardiac output and arterial pressure in our body. There are three hormones that involve in this system, which are renin, angiotensin II, and aldosterone. In this diagram, it shows how RAAS works and its actions on the body. I will explain more further in the next slide. The first stage of the RAAS was the release of an enzyme known as renin from the kidney. To be specific, these enzymes are released from granular cells of the juxtaglomerular apparatus or JGA. The release of this enzyme because it responds to one of these three factors. The first factor is because of the activation of sympathetic nerve where JGA are stimulated by sympathetic via beta-1 adrenal receptors. The second factor is because of the reduction of perfusion pressure in the kidney, which are detected by the baroreceptor in the afferent arteriole. The third factor is because of the reduction amount of sodium that delivered to the distal convoluted tubules of the kidney that detected by macula densa cells. The release of renin can be inhibited by atrial natriuretic peptide or ANP, which is released by stretched atria in response of increase in blood pressure. Angiotensinogen is a precursor protein which is produced in the liver and is found continuously circulating in the plasma. The release of the renin will cleave the angiotensinogen to form angiotensin I. Then, angiotensin I will subsequently converted into angiotensin II by angiotensin converting enzyme or ACE. The ACE are produced by vascular endothelial cells of the lung, and this conversion of angiotensin I into angiotensin II are mainly occur in the lung. Moreover, renal endothelium also generate ACE, but in a small quantities. Angiotensin II will bind to various receptors throughout the body to exert its actions. It will bind to the one of the G protein couple receptor, which are AT1 and AT2 receptor. However, the AT1 receptor is where the most action will occur. This table shows the outline of angiotensin II effect at different points. In arteriole, it will cause vasoconstrictions. In the kidney, it will stimulate the sodium-ion reabsorption. In the sympathetic nervous system, it will increase the release of noradrenaline. In the adrenal cortex, it will stimulate the release of aldosterone. Lastly, in the hypothalamus, it will increase our thirst sensation and stimulate the release of antidiuretic hormone or ADH. Now, I will pass to Muhammad Zulhilmi to explain about his part. Thank you.
Assalamualaikum and good morning. I beg to my lecturer, Dr. Ashila and fellow friends. I am Zuhilmi. I'm going to continue my friend presentation about RAAS system. Continue what has been left before, I will be explaining about the effect of angiotensin II. First of all, angiotensin II acts on AT1 receptors found in endothelium arterioles throughout the circulation to achieve vasoconstriction. This signaling occurs via a GQ protein to activate phospholipase C and subsequently increase intracellular calcium. So, the net effect of this is an increase in total peripheral resistance, in simply meaning the blood pressure in our body. Next. Firstly, the angiotensin gives out the neural effect. Angiotensin 2 acts at the hypothalamus to stimulate the sensation of thirst, resulting in an increase in fluid consumption. This helps to raise the circulating volume and in turn blood pressure. It also increases the secretion of ADH from the posterior pituitary gland, resulting in the production of more concentrated urine to reduce the loss of fluid from urination. This allows the circulating volume to be better maintained until more fluid can be consumed. Second, angiotensin 2 also gives out the renal effect. Angiotensin 2 acts on the kidneys to produce a variety of effects, including afferent and efferent arterial constriction and increase the sodium plus reabsorption in the proximal convoluted tubule. These effects and their mechanisms are summarized in the table below. As you can see, this table shows the various effects of angiotensin 2 in the renal. I'm not going to explain in detail about this because my friend will be explaining in detail later. So, last but not least, angiotensin 2 also play an important factor in tuboglomerular feedback, which help to maintain a stable glomerular filtration rate. Then, the local release of the prostaglandins, which result in predifferential vasodilation to the afferent artery in the glomerulus, is also vital to the process. So finally, angiotensin 2 on the adrenal cortex will stimulate the release of aldosterone. Aldosterone is a mineralocorticoid, a steroid hormone released from the zona glomerulosa of the adrenal cortex. If you still can remember, we have learned this before. The release of the aldosterone causes the excessive sodium reabsorbed at the distal tubule and collecting duct of the nephron and pumped into the blood by the sodium-potassium pump. In exchange, potassium is moved from the blood into the principal cell of the nephron. This potassium then exits the cell into the renal tubule to be excreted into the urine. Resulting increased level of aldosterone cause reduced level of potassium in the blood. Therefore, increasing of sodium in the body leads to an increase in osmolarity and subsequent increase in blood and extracellular fluid. That's all for me. My friend will continue this presentation later. Thank you.
I am Lena and I will present about the RAAS in our urinary system. Okay, yes, RAAS also plays important role in our urinary system. Okay, as we know, RAAS stands for the renin, angiotensin, and also the aldosterone system, but majority hormone that involved in urinary system are angiotensin 2 and also the aldosterone. So what RAAS do? So first, it stimulates the sodium reabsorption. Second, it stimulates the antidiuretic hormone and also control GFR. Okay. First, let's see about the reabsorption of the sodium. Okay, we need to know that angiotensin 2 triggers the secretion of the aldosterone, and aldosterone will be secreted by the adrenal gland. So what is aldosterone is actually do is it could increase the reabsorption of the sodium. So the amount of the sodium that will be reabsorbed back into the body will increase. Plus, aldosterone also will increase the secretion of the potassium. So the amount of the potassium that will be secreted by the body will increase. Okay, now we move to the stimulation of the antidiuretic hormone, or we call it as the ADH. Angiotensin 2 stimulates the ADH to be secreted by the posterior pituitary gland. The main action of the ADH in the kidney is to regulate the volume and the osmolarity of the urine. So it acts at the DCT and at the collecting duct. So it results in the production of more concentrated urine to reduce the loss of fluid from the urination. Okay, lastly, What RAAS do in our urinary system is it controls the glomerular filtration rate, or we often call it as the GFR. Okay. It begins when the angiotensin II constricts the peripheral arterioles and further it constricts the efferent arterioles. So this will cause the increase of the glomerular pressure. With that, the glomerular filtration rate, or GFR, will also increase. Okay, that's all from me for the RAAS in our urinary system.
Hello, my name is Nur Naimah binti Safari, metric number 055374. I will explain about the part RAAS and blood system. Firstly, what is the function of RAAS in this blood system? It is to regulate the blood volume by just adjusting renin level in circulation. And also, it also can regulate the systemic vascular resistance. What is the important member of this renin-angiotensin system? It is renin, angiotensin 1, angiotensin 2, and also angiotensin converting enzyme, which is known as ACE. ACE. How do actually RAAS involve in regulating the blood volume? First, when the blood pressure drops for any reason, whether the blood volume or sodium levels in the body are low or blood potassium is high, the granular cells of the renal juxtaglomerular apparatus in the kidney will detect the change and release renin into the bloodstream. Then, the renin will convert angiotensinogen, which is produced in the liver, to become hormone angiotensin 1. And then, angiotensin 1 is then converted to angiotensin 2 by angiotensin converting enzyme ACE. This conversion occurs mainly in lungs, where ACE is produced by vascular endothelial cell. Although ACE is also generated in smaller quantities within the renal endothelium. Angiotensin 2 then will cause the blood vessel to constrict, which will increase the blood pressure. So, the blood pressure is back to normal. Angiotensin 2 also will stimulate the release of hormone aldosterone in the adrenal glands, which cause the renal tubules to retain sodium and water and then excrete potassium. This means that the aldosterone will increase natrium ion reabsorption, which result in increasing blood volume. Hence, blood pressure is back to normal. So, together, angiotensin 2 and aldosterone work to raise the blood volume, blood pressure, and sodium levels in the blood to restore the balance of sodium, potassium, and fluids. Also, if the renin-angiotensin system becomes overactive, obviously it will cause the blood pressure rise consistently. So basically, this is the mind map for the renin-angiotensin system that are correlated to blood system. When there is a drop in blood pressure or drop in fluid volume, the renin will be released from kidney, and then renin will act on angiotensinogen to form angiotensin 1. Angiotensin 1 will then convert into angiotensin 2 by angiotensin converting enzyme. After that, the angiotensin 2 will work on adrenal gland to stimulate the release of aldosterone. The aldosterone then will act on the kidney to stimulate reabsorption of salt and water. So, the fluid volume will be increased back to normal. Angiotensin 2 also will work directly on blood vessels, which will stimulate vasoconstriction, or the blood vessels will be narrowed. So, when the blood vessels is narrowing or vasoconstriction happen, the blood pressure will rise back to normal. That's all from me. Thanks.
I am Zaika and I will present about how RAAS works toward nervous system. Okay. First, angiotensin II acts on hypothalamus to stimulate sensation of thirst. Then, it will increase of fluid consumption. Increasing of fluid consumption will raise the circulating volume and blood pressure. It also increases the secretion of antidiuretic hormone from posterior pituitary gland. Then, more concentrated urine will produce to reduce the loss of fluid. RAAS works toward nervous system by presence of angiotensin II. The presence of angiotensin II can release of noradrenaline. Noradrenaline is a hormone that responds in stressful situations, which is fight or flight. The result of releasing of noradrenaline will increase in cardiac input, vasoconstriction of arteriole, and release of hormone.